This lesson is on ellipses. Let's start by looking at the equation of a circle. X squared plus y squared is equal to 1. This, of course, is specifically the unit circle. It's where its radius is just 1. You can kind of see that the x's and y values can never go past -1 or +1, because then there's no way this could be true. You would have a bigger number would have to be equal to 1, which might not work. Let's try playing with this a little bit. What if I said x over 2 squared plus y squared is equal to 1? Well, now my x value, in order to remain within this range of 1, can go from -2 to 2. And you can see that. If I say x comma y is equal to -2 comma 0, it works. I can go that far, but here it wouldn't work. So now let's think about them graphically. In the case of a circle, it's just that, a circle. What about in the red case, the case where we changed x so it could go from -2 to 2? Well, the y values haven't changed, so we can expect these to be the same for sure. But it's like we're stretching it out so that it can fit more x values. And by stretching it out, we're taking the circle and making it look like that. An ellipse. You could do the same thing for the y value, and you could even stretch both of them. There are two special forms to write an ellipse equation. Here you can see it. Now, keep in mind, to relate this to what we were doing earlier, that x over a squared is really just x squared over a squared. So all we're really doing is stretching out the x and y values to go, x in the first case goes from -a to a, y goes from -b to b, and in the lower case it's pretty similar. So, if these are the two forms, well, what's the difference? I mean, you just switch a's and b's. And this is something that's very special about ellipses, and it has to do with what's called the major axis. The major axis is, if we draw out the ellipse, the longer side. In this case, the major axis is horizontal. The major axis could also be vertical, because there is no preference for direction in math. There's nothing stopping us from doing that. So how do we specify this? Well, these equations are important when A is greater than B. Could also be equal to. Of course, if A is equal to B, you just have a circle. But anyway, we use this to choose which equation we use, the top one or the bottom one. And it's because A always represents the major axis. And what I mean by that is, so here I'll draw another ellipse. The major axis has endpoints. The farthest reaches of the ellipse. There's a line connecting them. Now, we decided that y could go to plus or minus a, if we look at this bottom case. So that means, if this is our horizontal line, x, there we have y, y could go all the way up to a and all the way down to minus a. Similarly, there's also the minor axis. And the minor axis is just the smaller one. The side of the ellipse that doesn't get expanded very much. In this case, it's here. And that, if we again look at this bottom equation, and of course the reason we're looking at the bottom equation is because in my drawing, A is clearly larger than B, because here is B. Every ellipse also has two foci. That's the plural for focus. In this case, you have a focus which is probably up here, and another one which is down here. They kind of tell you a bit about the ellipse. They always lie on the major axis, but how far away depends on the minor axis too. If I say this is at a distance c, and down here we have minus c, then c is going to be equal to the square root of a squared minus b squared. Ellipses can have a more general form. The ellipse we used for those examples had a center at the origin. But what if it wasn't centered at the origin? Much like with a circle, we could have a circle with a center anywhere we want. So, just as we've done with circles, I can take my original equation for an ellipse and just shift it over so that it has a new center. So these equations have a center at x1, y1. The major and minor axes for these ellipses have endpoints that are just at the center, and then you go plus or minus a along the major axis and plus or minus b along the minor axis. I've written down the coordinates of those endpoints so you can take a look. The foci of the ellipse use c, which is equal to the square root of a squared minus b squared, and they are at the center but plus or minus c along the major axis. You could also think of the major and minor axes as just those segments connecting you from the center plus or minus a for the major axis or b for the minor axis along the corresponding axis. That's kind of a mouthful, but just think of it as, in this first case, your x's go plus or minus a for the major axis, and your y's go plus or minus b for the minor axis. And you could do something similar for the case of this ellipse. We've covered a lot of material in this lesson, so please look at the examples for further insight on ellipses.